Hi, my name is David Lee, and welcome to Astro Cafe, April 14th, 2025. First I'll ask, is anybody new here? Or does anybody want to say something tonight that I don't already have? Okay, I think we have a full slate tonight. Kirsten, it looks it might be quite full, so if you want to wait till your part two, until your session, you're more than welcome to do that. All right. Okay, so I guess everybody's been busy. I hope there has been some good weather. And I think what I'll do is I will start off with some events to come and events that happened already. So I'm just going to move my share over. So I'm going to ask, did anybody see the moon on the 12th? Anybody other than the people that were up on the
Later,
hill?
later,
Oh, later. Okay, we'll talk
later.
about that. We'll talk about that. So on April 12th, around 8:10, a group of us met up at the hill in a parking lot between the new building and I guess it's the tool shop or the machine shop. And we kind of waited around. We had a lot of gear out, and I think there was maybe about eight of us, I guess. And we witnessed this event, and I've been looking around, and of course, people have been telling me what it is because it has so many different names. I happen to call it the pink micromoon, and I'll talk a little bit about the micromoon in a second. But it also has a Pexon moon, which is from the Wasanic peoples, and the moon of opening hands. A lot of the names are associated with the coming of spring or flowering blossoms, and Paschal moon, Easter, and Passover moon. Let's see here. All right. So after
Hey, David.
after going through a bunch of haze and stuff, which you'll see in my last picture, it did finally appear. It was quite fractured. I'm going to show you some pictures of the event with people around, and thanks to Wyman for taking these pictures. But
Hold
before I
on.
do,
Go back,
yep,
David.
yes,
Back.
yep,
Do you notice how it's on its side? The north is almost perfectly to the left.
yes, yes. Now,
Tritium is the dot up at the top. And that's usually on the east side.
well, the orientation of the camera, I wasn't really that careful with,
But
so
also it's because it was the moonrise
yes,
and it's got a full
Oh, right.
12 hours these days.
yeah.
So going from being on
I
its
tried, I
side.
tried to, I tried to make it as level as I could. But yeah, the orientation kind of can vary. Obviously, it can vary depending on what people do. As a standard, I've been trying to uh, put Copernicus at the bottom, right, and orient it that way each time. But I didn't do that this time. So Lauri asked a really good question when I was announcing some of this, and she said, "Nobody's going to know what a micromoon is, and what's a supermoon and stuff like that." So I got this from the NASA website, and here we go. Perigee and apogee have are conditions where the moon is farther away or closer to us. So perigee is when it's closer to us, and those are called supermoons. And when during apogee, which was this case, they're called micromoons. So you can see the stat here. The supermoon's 14% brighter, and sorry, bigger and 30% brighter than the micro. I don't know if I noticed that, but yeah. Did anybody notice the people that were with me? Did you notice that it was smaller? I don't hear
A lot
anybody
of
saying.
people were bitterly disappointed with the size
They
of those.
were they? Yeah, okay.
I measured it with my sextant, and it is indeed down at about 29 minutes.
Oh, wow. So you did measure it.
Oh, I
Ah.
measure the moon every time I see it.
Oh, okay. And it's definitely smaller.
Oh, yeah,
Ah,
And what do you get when it's perigee?
32.
32.
Yeah.
Okay,
well, there
so
you go.
Up to
There you go.
82.
Cool.
David,
Yes.
I read that that micromoon is 6% smaller. Don't know.
6% smaller. Okay.
Correct.
Okay. I don't have that stat on here, but that's interesting. Yeah.
If the supermoon is 14% bigger but 30% brighter, that implies that its albedo is 16 percentage points higher, which makes no sense to me. How can that be?
Hmm.
No, no, this is the square
square
of
root
the
of
area.
difference.
Right here.
Yeah, I don't know. I can't answer that question, but
Okay,
Square of the
14%.
diameter.
Oh, that's diameter.
Yeah,
Okay,
mhm.
14%.
yeah.
1.14 squared. Okay.
Okay. Does that explain it or
Partly.
partly? Okay.
And it's closer, so there's less inverse square.
So there we are. I had way too much equipment out. I had my Pronto refractor there, which I'm kind of kind of setting up right now. And Brenda's beside me, and there's Kirsten. I also had the tracking mount going as well. And I can't what's Zen's wife's name? I can't remember her name. Does anybody remember her name?
Who
Anyways,
is this?
Zen's wife,
It's
Renee.
Renee.
Renee, isn't
Yeah,
it?
yeah.
Yeah. Okay, Renee's there in the middle, and actually, I was quite intrigued by this. Zen had made her a binocular mount for her birthday, and
Nice.
I think it's 3D printed or something like that.
Yes.
It was very nice.
Yes. Yeah.
Yeah,
I
very
I
very
would
nice.
never have known that. I actually found that out the following day
Oh,
that it was 3D printed, but I guess it was Brenda who got the goods on it. But I mean, I guess it was plastic, but it sure didn't look like it. It looked very robust. It was very good.
very nice. I guess Zen knows what he's doing. Yeah, and then there was Susan was there, and Denise was there. Wyman's taking the picture. That's why he's not in here. But you can see the moon hanging over. This must have been the earliest time. I don't know who spotted it first. Wyman, did you spot it first? Somebody yelled out and they saw it.
I
I
think I think it was me
so
actually.
Did you
yeah,
say it, Kirsten? Sorry.
Yeah.
Okay.
Yeah.
yeah.
Your eagle eyes.
Yeah. I was
Yeah.
like, oh wow, it's there.
You have to signal better next time, Kirsten, so I know it was you. Yeah. So when you saw it, was it covered up at all, or was it perfectly clear?
Well, actually, it was emerging f from I guess, probably cloud. It was kind of a dark horizontal band of cloud that was very close, if not directly, just on the horizon and obscuring it. And we were looking in that direction, and then I looked back, like it seemed just like a second or two later, and what had happened is you could see like the tip, like the just this a small little piece, a little tiny bit of crescent had just emerged from the
Right.
horizontal band of cloud,
Yeah.
sitting just above the horizon. But what I noticed right away was it was exceptionally bright. Even that
Mm.
little band of brightness, and then the rise when it happened, it seemed to occur very, very quickly. Like the little bite just grew in size, just very quickly.
Mhm.
And despite it being I guess a micromoon, I, I personally I didn't really notice that. I was so um impressed by the brightness and the color of that particular moon that the percentage different in size was just kind of lost on me.
Yeah. And it's quite possible that we can see a counter effect um from the optical illusion of the moon being near the horizon as well. So yeah, it was very, very beautiful. Like it's you know, in spite of the photographs I was able to capture, I would say they were so-so. But you know, the most remarkable thing was the view actually through the Pronto, actually,
Well, that's a
and through
fun
binoculars.
picture. That's great.
That's a fantastic picture.
Love it.
So there you go. Yeah, yeah, that's a good picture. Wyman did a good job
Why were you at that parking lot instead of next to the dome?
because this is the best view.
Okay.
I've scouted it before. We've done lots of easterly views from this parking lot. It's my little secret. So
There's a
There's
lot of trees up by the dome.
Yeah, there's
yeah,
no immediate trees. You have to
Ah.
dodge trees when you're
You
on
have to
the
dodge the trees.
Yeah,
True enough.
I've been up there doing moon stuff on a one of the open nights, and
Yeah.
you're forever moving.
yeah,
And keep having
it's
to move the telescope. Yeah.
yeah,
Yeah.
it's a good spot. We've had actually some public events there, but it gets
Mhm.
kind of crowded. It was just right for us, you know. There was not that many people, and we all had lots of space.
I can recall being there for eclipses of both types, you know.
Yeah, yeah, for
Yeah.
sure,
Yeah.
for sure.
Yeah.
You know, there was that great
We had another one there.
lunar eclipse of 3 or 4 years ago where we were there.
Yeah.
Mm.
And then the solar eclipse, you know, the one that was kind of clouded out at the last yawning second,
Yep.
all a couple of years ago, we were
Yeah,
there.
I remember that. Yeah. Yeah, here's another shot from Wyman. Wyman, this must have been just zoomed in on your phone, right?
Yeah, it just zoomed in on the iPhone. It's a bit fuzzy, but it gets a good shot.
Yeah, captures the moment. Yeah. Oh, this is nice. I love this one. Actually, my first opening shot is overexposed, and it was of this environment where there was a band of cloud. And it was very, very pretty. It was almost like a bright object, and then kind of like a halo around everything. Very, very nice. And this looked absolutely gorgeous in the refractor. And these are some
They're pretty.
shots. There's the opening, and there's when it's kind of peeking up. And I think that's one of the probably near the last shots that I took. So I'm planning on doing a more full mosaic, but I didn't really have a lot of time, so that's what I did. And later, we were expected up at the VCO because this was like a opening act to the VCO session for that night. And we went up to join Reg and John and I think CJ. CJ was there too.
Yeah.
And the two Chris's.
And the two Chris's, of course.
Yeah.
Yeah, Chris, the new Chris that I don't really know.
Yeah, Chris Irvin. Yeah.
And the Chris who's speaking.
Yes. Yeah.
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 So yeah, we had some problems, but to be expected. It's computer stuff. So the main problem was that we couldn't get the time to work properly. So I'm going to have to install the GPS again. We just don't have enough of a reliable internet up there to live on internet time. There's me trying to figure out what happened. Yeah, there's a whole bunch of us there. Oh, okay. So that's the end of it. Any questions about the session? I think anybody who was there, does anybody want to add any comments?
David, I've got a question. Who had the authority to assign the word micro to the moon? Where'd that come from?
I don't know. I don't know.
Okay, I think the supermoon started with some astrologer, and quite
Oh,
recently,
that's right. That's right. I
in
remember
the
that.
last 10 years or so,
Yeah.
and then the micromoon got you know, used in contrast to the supermoon. But the
Right.
supermoon definitely is not a classic term, and it was an astrologer who assigned certain significance to it.
Why pseudo, not mini?
Okay,
Or
I would have thought mini was a more appropriate, but I looked
A
in.
mini moon. Oh,
what is
Okay.
the opposite of superior or super? And I came up with a whole pile of lists.
Inferior moon?
They include the words lousy, rotten, terrible, atrocious, appalling.
An atrocious moon. There
Yeah,
you go.
but one that mediocre, pathetic, unacceptable, dreadful, shoddy, subpar, junky, worthless. But one that seemed to be more appropriate instead of superior, it would be an inferior moon. So that has kind of a balance to it. So
Oh.
I at any rate, if you're using NASA speak, they always say things are nominal, and if they're not nominal, they're subnominal. That usually means that the spaceship blew up.
They have wonderful euphemisms, don't they?
Why don't we call it an apogee moon and
We could do that. We could do that. Yeah.
Oh,
Much more
very
accurate.
Moon and perigee moon, right?
Yeah.
I prefer perigee moon and apogee moon, but
It sounds astronomical.
yeah.
It's not going to make it into the media.
No, it's not.
No.
No.
When you say micromoon, it sort of seems like the opposite of that internet thing that went around,
When
everybody
Mars, so
with
yeah,
the
Mars
opposition
was going to be
happened,
huge.
and
Yeah.
it's going to be
Yeah.
as big as a full moon and all this stuff.
Yeah.
So, David, I
Years
detect a
afterwards.
fair amount of disgruntlement about the term.
I see that. I didn't know I was going to bring up a controversial topic.
Is it micro disgruntlement or mini disgruntlement?
Oh, I don't know.
Macro. Yeah.
Macro. Oh, I like that one. Macro.
Macro moon.
Micro and macro.
Yeah, that is
That would
acceptable.
be better. Yeah.
Okay, I think we better move on. So the other thing that we talked about at the meeting up at the university was Comet Swan. So here's a picture. This is Dan Bartlett's picture of Comet Swan. So you may ask, why is it called Swan?
Why is it called Swan?
This is the reason. This is the reason why. So there's a swan, solar wind anisotropes. I don't even know how to pronounce that.
Anisotropy.
Oh, thank you. Okay, Swan camera on Soho. So that's how it gets its name. And yeah, it was discovered. Now, anybody who wants to try this can't be faint of heart because this is really early morning. I don't know how many early morning astronomers there are here. I know that Randy can be, but I'm not sure about anybody else. And Alex can be as well.
4:15 a.m.
And David.
And David.
What magnitude?
Pardon me?
What magnitude is it currently?
According to this, Sky Safari, it's 7.8.
Ooh. Yeah, I don't do 7.8 under my streetlights.
Yeah, this is a photographic, I think, object, unless you have a huge telescope. You might see it in binos, but I doubt it.
I heard somewhere was a bit of a disappointment that it wasn't quite working out the way people thought.
Well, it can be that way with comets, right? They can be amazingly nice and then amazingly disappointing. Maybe we need some adjectives for that, Reg. Can you work on that?
I'll get right onto
it. Something that's synonymous with disappointing, right? Yeah.
Oh, David, can you go back to the picture?
Yep.
We could call it the green flash.
The green flash. Yeah. That's good. That's kind of, well, yeah, a lot of them are green. A lot of the heads are green. Actually, this really reminds me of Hyakutake from 1996, I guess. Like the trajectory of the tail was very spear-like, and that's what this one looks like.
Yeah, I like that. That looks really cool.
Yeah, it is. It is.
A pretty one.
Very cool. So anybody who attempts this, hats off to my hands off to you. I'm gonna try. I don't know how often I will try, but it's worth at least one or two tries, I think.
Well,
How long is it in the sky, David?
Okay, so I would start anytime you get a clear morning now, because by the end of the month, it's going to go lower and lower and lower, and then you're fighting against dawn. So you're not going to win. So
Even at
yeah,
4:15, you're getting close to it too, right now.
you are, and you know the pending dawn is your big enemy, right? And of course, you don't want to get blinded by the sun either. But I mean, there are some interesting treats at that time of the morning. Venus is going to be around, and Mercury and Neptune. But I don't know, it's worth it just for that.
Is
Anyways,
it
that's
incoming
good.
or outgoing?
Pardon me?
Is it incoming or outgoing?
I think it's headed for the southern hemisphere, I think.
But is it past its perihelion?
I'm not sure. It might be at the end of the month, it might be at perihelion. Yeah. I'd have to check on that one. Okay, so if there's no questions, if there are questions, please contact me and I'll see if I can find out the answer. All right. Okay, let's see who's on the agenda tonight.
David,
Yes,
while talking about the morning sky, can I show a couple of pictures?
absolutely. Go ahead.
Help if I say share. Come on. Share screen. There. And
There we go.
The other end of this.
okay, so this was just a few hours later. I went up to King George Terrace. I did watch the moon go down, but it was I woke up at about 5 and watched the moon go down. Then I got in my car and went up to King George Terrace, and sunrise was at 6:26, but it was behind those clouds, and so I didn't actually get this picture till probably about 6:40. But it was really pretty. But while I was waiting, I was having fun locating Venus in the brightening sky, and I kept being surprised at how well I could see it. Anyway, I put my camera on kind of a high-speed repeat, and I got this bird flying by.
That's great.
Now, does anybody, you see Venus there, I hope?
Yes, I do.
Does anybody know how to do that sort of picture where you superimpose all the birds?
Yeah, you just have to take if you don't have individual frames, you can
These are
take
individual frames.
you can they are individual frames.
Yeah, these are
It's a
each.
movie.
Okay.
It's not a movie. It's a series.
Then
Oh,
you
I
put
know.
you put them into layers, like in something like Photoshop,
Yeah.
and then one of the blends will superimpose them together.
Okay, in the program I was using, I couldn't find it,
Hmm.
but I think this might be a nice. I think this might be a nice set of photos.
Yeah, I think it would be actually. It'd be kind of neat. You don't have to pick every one, like create some spacing between the frames, right? And then you could.
I might send you the series and see whether you can do it.
Yeah, you could do that. I could make one.
So you got photo bombed, which is better than the usual type of bombing you get from those birds.
Yes, for sure. Okay. Let me think. Why don't we break this up and have a few announcements? Randy, you want to talk about International Astronomy Day?
Yes, so May 3rd, Saturday, May 3rd is coming very quickly. And so first of all, just to remind everybody, the flow of the day is the tables and things are going to be set up at the museum, at the Royal BC Museum, on Friday evening. We are welcome at 9 o'clock to come and set up our equipment. I still have to talk to Kim Goff about if they'll put the bollard down and we can drive right up, but they didn't allow us to do that because of construction at the International Geodiversity Day. So that's something to find out. We might have to carry equipment in, and so let's be nice to Bill Weir and help him.
I think the construction's complete, isn't it, Lauri?
It's pretty close.
Yeah.
I think it looks pretty good there.
Okay.
And Randy, let me do that. I'm kind of doing some of the stuff at the museum, so let me look at after that.
Yeah, Lauri's the site manager.
Yeah.
Okay, and then we will have a variety of tables. The kids who we awarded prizes in the science fair will demonstrate their posters. We have UVic and Camosun and a couple of schools and the FDAO, and of course we'll have several displays, and we can use more volunteers to help out. And then we also have a speakers series, which Kristen has set up. And we have an organizational meeting tomorrow evening. And if you write me at pastpres@victoria.rasc.ca, then I'll send you the link. And we're approaching getting ready. We have publicity close to being lined up, and the museum will be sending it out to all of their email list. And looking forward to a good day of outreach.
Just for people's information, that planning session is really important because we want to make sure that every lead is in line now or know that they're a lead because they're the ones that we're expecting that will get volunteers.
And then the FDAO is running the second part starting at 7:30. Although, Lauri, what's happening with the cross-country video?
Well, that I needed to kind of talk with people because we're at the end. So they're wrapping up at like 11 of the at the ending time, like out east, which means that's 8 o'clock for us. And so we have been given a time by Kareem from 7:45 until 8 that we can be online live. Now that's a little bit, I mean, it's rather a busy time because the kids are kind of coming out and people are going in. But in fact, that's exactly what happens at a star party, and that's what they want to show. So I'm hoping that maybe there might be a couple of people who I can call on to just be working on that part and make sure that we get on the Zoom call, and then it'll all be finished by 11 o'clock, by 8 o'clock, and everything can just go back to normal. But I'll need some people between about 7:30 and 8, just even a couple of people to handle things like a camera and an extra Zoom call. And then we could just simply do a little bit of a hello, this is where we are. This is what's happening. I don't want to kind of wander around and go over to the dome or do anything like that. There's not enough time to do that. So and I think that that's actually easier than if we tried to do a pre-recorded segment. If we did that, there'd be nobody there. It would be empty. So it wouldn't be looking very, very much fun. And I just think it would be a little bit more sterile looking than if we just had a whole bunch of people around and things like that. So we're just on for like literally maybe 10 minutes worth from about 7:45 until about 5 to 8 or so.
Yeah, I mean, it can be as simple as just using an iPhone or something like that. We could patch you in. In fact, we've done that in the past. We've just put a iPhone on a little mini stick and just walked it around.
Just walked it around. If it's
Yeah.
nice, we can have people outside. We can start outside, with looking at the dome and looking at the view, and then go inside and kind of get everybody to wave and say hello to people across Canada. We can let people know that they're live on camera across Canada, and we'll be the end. So they're starting in Halifax and ending with us. So there we go.
There you go. So it'll be darkish. It'll be dusk, I guess. By time.
Duskish, yeah. So,
Yeah, that'll be nice.
So Randy, I also sent you today the list of movies that the IMAX is going to be
That's awesome.
having
They're
at the
super.
Yeah, so they'll be doing it actually Friday, Saturday, Sunday. They're going to be running astronomy movies. So that will be so we can put that on our website if we can. Is it Joe that you put things on? Is that who I talked to about putting things on the website, or how do you want to do that for Astronomy Day, Joe?
Yep,
Well,
by all
we're
means,
just
that's what we did last year. We publicized it on our event page. So
yeah.
give
So
me the links to the videos, and I can embed them right in the page.
yeah, so
Okay.
basically what the workflow is that we get the press release finished, I'll get the poster finished, and I already sent Joe a mock-up, so we're gonna make sure that the link that is in the poster matches the link that he has on the website, and then we feed everything to Joe because the up-to-date information is actually on the website, not on the poster.
Right. Okay, Kirsten, do we have a list and a schedule for the speakers?
We'll set the timeline tomorrow, but we've got the 4.
Yeah,
Okay, because
sorry,
the
I didn't realize actually I was supposed to be doing that.
Oh.
What I can say out of that is out of the 3 speakers that I contacted, one,
No, Brock is
Nathan.
in too. Brock is in also.
Great, thanks, Randy. Nathan is the only one who specified an actual time that he needed to speak at 10:30, because he has to be away by noon. So but I think it's still a question around what will work for the other 3.
Okay, we need to get this to the museum because they publish that schedule in their calendar, and they need it within the next day or 2. So if we can I mean, even if it's like if it changes on the day,
It's okay, right?
We can put something in for them so they can put that on. That's all that we need.
That's
Okay,
perfect.
thank you.
Chris, is the press release almost ready to go?
Yeah, pretty well. I sent around a draft, kind of, what was it, last week?
Oh,
and
okay, excellent.
It would take me about 10 minutes to fix it up, and and
I've got a few.
I'd like to get it out before the Easter weekend.
Oh yeah, no. Tomorrow.
Yeah.
No, I will have it. We can have it all ready for you for tomorrow.
Yeah, I'm planning on finishing the
After the meeting.
poster about the same time. Like I'm just going to reuse what we had and just replace the speaker information. So it should be pretty quick.
Yeah.
All right. Okay, that sounds good. Randy, do you want to give us part 2 of the Zodiacal Light?
I will do that. And this is, again, in response to Natasha's request to talk about the Zodiacal Light and my realization that I knew nothing about it. And then my realization that it was a very rich topic. So just to introduce it, here is a picture that Joe took. Was this at Gary's place?
Yes, this was from Southern Arizona.
So what you see is the Milky Way, which, as I hope everybody knows, is a pile of stars. But then over here is this terrible light pollution. What's going on? Well, it's called the zodiacal light because, well, let's see. Here is Orion. You can see, you know, the belt and the sword here. And then you follow that along and you get to
That'd be Taurus.
yeah, there's Taurus, and over here you can see the twins Gemini. So this is the zodiac line or the ecliptic, and this light is going and polluting the zodiac constellations. Okay, so this is a perfect picture of the zodiac light, but it is very diffuse and you'll only see it in a really dark sky like at Gary's old ranch. So
question.
Yeah, Leslie.
Zodiacal light or zodiacal light?
Anybody going to express an opinion? This is a new word for me. Gary, you watched it all the time. What did you call it?
That glow in the sky.
I normally call it zodiacal.
I think it's zodiacal. Good shot, Joe.
Zodiacal, yeah.
Yeah.
So I ended last week's talk with Brian May's comic or cartoon or artistic rendition of where the dust likely was based on how it reflected light, the sunlight back to the earth. So in his diagram, we have no sun in the middle. That's been suppressed in this picture, but you can see, where did my mouse go? Mercury, Venus, Earth, then Mars, right in the middle of this kind of donut torus of dust. And then Jupiter is the outside edge, there's Saturn. And then he shows that it's likely this dust is caused by comet dust coming off the comets as they fly past the sun, or with this ring here, that's supposed to represent a couple of asteroids that crashed into each other. And this is very shortly after the crash. And then through various forces, it gets brought down to the ecliptic. And that was a pretty good understanding at the time. So this is kind of what I'm hoping I got across last time, that this light pollution is dust and 1 to 30 micron. Remember, a micron is 1,000th of a millimeter. And so, you know, you can see 30 micron, but it's really small. You can't see 1 micron dust particles by themselves. They're mostly around the ecliptic plane meaning that plane that's defined by the Earth's rotation orbit around the sun. And it's in a torus, it's a bagel. And that the limits are somewhere between the Earth and Jupiter. And they mostly just follow the same rules of planetary motion as the planets. So like Kepler had worked out. And the smaller particles aren't there because the solar wind just pushes them away. And there's this really weird effect, which they write about as something like what happens when you run quickly into vertically falling rain. You get hit in the front by the rain as you're moving through, and that will slow you down a bit. And as you slow down, then you have less centrifugal force, and you'll fall in towards the sun. So if you're too big, then you get more of that rain hitting your front surface, and so that slows you down. But the thing is, this has to be replenished because the dust will not last the 5 billion years since the solar system started as a nebular cloud and turned into the sun and the planets. No, this stuff is really recent, 1 million years only. And so where does it come from? Is it comet dust? Is it broken up asteroids? Well, the big change in the understanding of the zodiacal light came when they started doing these survey telescopes in outer space. We can see a little bit of infrared light from Earth. This is where there are these bands, these frequent or wavelength ranges that you can see through mostly the water in the atmosphere that absorbs the infrared. Well, all the greenhouse gases are the ones that are absorbing the infrared. So you can see a little bit, but in order to really get a good view of infrared light, those longer wavelengths, you have to be outside the Earth's atmosphere. And that only started in 1983 with IRAS, the Infrared Astronomy Survey, something like that. And then a few years after that was COBE, the Cosmic Background Explorer, which had an infrared mapper on it. And so this particular plot puts the galaxy right along the middle, but this great big S here, that is along the ecliptic. That is in the plane that the Earth orbits the sun, and that is that dust that we see from Gary's old ranch that Joe took the pretty picture from. Okay, so yeah, so this is what 1984 was the first study from the infrared astronomy satellite. That's IRAS. IRAS is the acronym for that. And so this is a whole bunch of well, actually, I'm going to go to the next one. This is one of those lines, and if you fit that fuzzy cloud with this, it's a Gaussian curve, it doesn't matter, but then you see that there are variations around the main trend, and there are these bumps, okay? This is the ecliptic latitude, so how far you are above or below the ecliptic, the Earth's plane. And you see what you have in the bottom is the kind of big black line minus the dotted line. This is the difference. And you see there's a couple of bumps on either side of the ecliptic. And then there are these kind of later bumps somewhere around 10 degrees. Okay? Fascinating. What does it mean? And all sorts of papers look at resonances between different families of asteroids. And, you know, there are questions why this family is making collisions and that family isn't. And, you know, there was a whole bunch of what in science we call special pleading. That is the worst thing you can say to a scientist. Well, no, there's lots of worse things you could say. Among the things that people use to discredit your idea is when you say it's special pleading. It's not following Occam's razor. It's not simple. It is asking for the universe to behave in a way that is not elegant. Okay? And so this was a beautiful set of data that needs to be explained in an elegant way.
Randy, what is the lambda minus lambda Earth there? Is that
oh, you know what? Well,
those are normally wavelengths.
Oh,
So
that
they
would
mean-
be, that's a good
oh yeah, it's the wavelength minus the sun wavelength.
Okay.
But why is that?
No,
Why is it in degrees?
Wouldn't that be a kind of a measurement of longitude? If that's a latitude, that's at a particular point that's looking out at me.
Ooh.
Yeah, what
Okay,
does that mean?
I have absolutely no idea. So that is, watch out.
I'm sorry.
When you ask a question like that, I sometimes look into it. So just warning you.
I apologize.
No, I'd like to know. I didn't even pay attention to that. Okay, so the other thing that you couldn't do on Earth is actually collect the dust. I mean, you can look at micrometeorites, and people have done that. And you can also take a look at the dust that settles on the moon, and they looked at that. Yeah, you suck up, you go high up into the atmosphere and suck up the dust that's up there, and the stuff that doesn't come from Earth, you figure is the same as the dust that makes this zodiacal cloud. But there has been a whole series of space probes that have been flying around the solar system, and they typically put on a dust collector. You'll see that the Voyagers aren't on that list, but they did have a way of measuring dust. They had a sort of plasma. Oh, somebody looked it up. Wade.
Ecliptic longitude.
The ecliptic longitude. Good for you. So, that's how far you. Okay, that's the elongation.
Yeah.
It's lambda minus lambda sun. So that's how far they're looking away from the sun's angle. So 282 means it's just over 90 degrees from the sun.
Okay.
Okay.
Very good.
Thank you.
Thanks, Wade.
Good looking up. So yeah, they measured the dust directly. And the dust counter that I spent most of my time looking at is the Venetia Burney student dust counter. So let me first of all talk about the student dust counter. This was plunked on the bottom of New Horizons. It was not part of the original science plan, and it was not getting funding, even though the people who are interested in this sort of thing said, come on, it's not very heavy. It's not going to take a lot of power. Give us some real estate on your space probe. And they said, well, find some funding for it. And they did by talking to NASA's EPO committee, the Education and Public Outreach Committee. And they pitched it that they would get the students at the Boulder Lunar and Atmospheric Science program, something like that, to design it. So this was, the NASA engineers had to supervise everything. And the professor who organized this said there was no compromise made for these students. And his conclusion in the end is, don't do this if you think you're going to save money. It costs the same as if the engineers had done it. But they got a whole bunch of highly qualified personnel. Many of them have continued to work at JPL or at their department. At the peak, they had 25 people working on it. And the other thing is, this is an instrument that's going to work for something like 40 years. And so it's going to be generations of students that are doing it. But after they assembled it, they called it Venetia Burney. So first of all, I'm going to say, anybody other than Chris know who that is? Chris, do you know who it is?
I think I have heard about it, but I can't remember.
She is the person, age 9 at the time, who named Pluto.
There you go.
Oh, Lauri says she knows. She just died, but she died after this was on its way to Pluto. So she got to celebrate all the stuff that goes along with going out to space. Anyway, it's a lovely story. Do I want to spend any time here? It's not big. It's 1/10 of a square meter, and has those 12 panels. And then there's 2 more identical panels, but they're underneath, so they won't see anything. And so that's how they could tell the difference between real signal and the spurious signals. And every 6 months, it phones home, and it says what the data is saying. And that's the sort of data that they're getting. there's a lot more dust out there than they were expecting. That's what this is saying. And by the time you're out at Pluto sort of distances, then that's interstellar dust and Kuiper belt dust. It's not the same as what we're looking at. The stuff that we're interested in is way up at the first like 3 AU is an astronomical unit, how far the Earth is on average from the sun.
Yes.
Okay, then comes the real reason, Natasha, that I'm writing this story is to tell you about Juno. Juno does not have a dust collector put on it, but a few things. Number one, it is very difficult for NASA to get plutonium for their thermonuclear generator. So heretofore, all the space probes that have gone out to Jupiter and beyond have had a little heat source heated by a hunk of plutonium to produce the energy. But it's turning out to be, I don't know whether it's expensive or for military reasons, they're holding back their plutonium in the States.
Political. Some people didn't want to have radioactive substances launched into space.
That could be, yeah.
They went into a different type mechanism, and so they didn't make the bombs that way anymore, so you don't get that byproduct.
Oh, okay. Anyway, the other thing is that solar panels have become more efficient, and so it's possible, it's conceivable to power a Jovian planetary probe with these like 60 square meter solar panels. And that's great, especially since Juno was designed to study the Jupiter's magnetosphere. So it needed a magnetometer, but that magnetometer had to be far, far, far away from all those nasty magnetic things going on in the middle. So you have to have a big boom to hold it out. Might as well throw some solar panels there.
Well, it needed the large solar panels because the light at Jupiter is 1/25th at Earth.
Yeah.
So
yeah. So it needs to be big. It needs to be very efficient. And the other thing about a magnetometer, so you need the magnetometer. It has to measure the magnetic field, but also you have to very accurately know what direction it's pointing. And there's a beautiful compass out there. It's the stars. So they have cameras. Actually, I think there are 4 cameras next to the magnetometer that every quarter second takes a picture of the sky, puts it into their, what do you call it? Frame, when you
plate solve?
Plate solving, yeah. So it plate solves to figure out exactly which
Where
way
it's
it's pointing. And they said, yeah, now, if we use this to look for things that aren't in the catalog, that will tell us if we see any asteroids or anything. And so they made it so that it is always looking 4 times a second, and if it sees something that's not in the catalog in 2 consecutive frames, it's going to phone home. And they thought they would get something once a week, once a month. And then what they discovered is they were getting hundreds or even thousands of signals a day in these cameras. And that's when they realized they had built, serendipitously, the largest dust collector. Instead of 1/10 of a square meter, this one is 60 square meters. Yeah. So what happens is when a sufficiently large dust particle, so unlike the other ones that could see the really tiny ones, this one it has to be like more than 10 microns in order to make enough of that. It's called spallation. And this is actual damage on the solar panel. Anyway, they figured from their modeling and everything, that they're looking at the larger ones. But that's good because those are the ones that we mostly see from Earth. And well, yeah, so let's take a look at the data. And for that, they turned those cameras on. So look, here is the sun in the middle and the Earth going around that blue track. Okay. And they sent Juno out beyond Mars, and there's a lot of vertical exaggeration because Mars is like 1.8 degrees off the ecliptic. Okay, so just imagine that this inclined oval, it's actually pretty close to the gray plane. Oh, and these are monthly dots. Those dots show where Mars is every month. These dots show where Jupiter is every month. Anyway, so it started off in the plane of the ecliptic, and then it did its deep space maneuver to change its orientation. Go back. And so it went, the darker thing here is between the aphelion and the perihelion of Mars. So where Mars is at its furthest and where Mars is at its closest. And then it got close to the Earth, but the Earth is over here now. And it did what's called the Earth flyby, did a big, not a ricochet, what do you call it?
They robbed momentum.
What?
They robbed momentum.
They robbed momentum from Mother Earth, gave it to little Juno, and then it went way up, but only actually 4 degrees off the ecliptic. So again, vertical exaggeration. And this path here is over where Mars is between where it's closest and furthest from the sun. Okay, so we have 2 encounters with that kind of Mars type distance, and then it continued on its way to Jupiter. Okay. I'm not going to spend a lot of time on this diagram. It is so rich, but this is starting from the maneuver that brings it back to Earth. And here it comes to Earth. Here's the flyby. So now it's going out for the rest of this. This is by date, okay? And it's flying away from Earth. It's kind of cool. It went through the tails of a couple of comets on its way to Jupiter. But you see, it was seeing like up to 250 events a day as it went through this. And this time, instead of by date, it's by position. So the way you read this is the top panel is inbound and the bottom panel is on its way out. The light gray is the number of asteroids. Oh yeah, they really didn't plan on this. So when the instrument, when its memory fills up, then it just stops measuring. And so it's not a continuous measurement. It would measure and then it would wait until it phoned home. And usually they did that every 6 days. So these are 6-day snapshots of how many dust particles they met. Very interesting how until they got to this distance, they didn't see any. And they figured that was because it's being swept by Jupiter. And this is the 4-to-1 resonance. So this means that a particle here would go around the sun 4 times for 1 time that Jupiter goes around. Anyway, there's no dust outside or towards Jupiter from here. And it goes up and down and up and down. So let's take a look at what they saw. And again, what they have for measurements is coming in along the ecliptic, past Mars, in past the Earth. And again, there's not very much there. And then once it hit the Earth, then it went off about 4 degrees off the ecliptic. Okay. And when you like project everything into one plane, like here, this is what they see. So in that infrared diagram that I showed a long time ago in this talk, with the 2 peaks in the middle and the 2 peaks out here, that is from the infrared astronomy satellite. And then the red is, after a lot of cooking, is what they got from Juno. And they said, holy, that's not a coincidence. That is saying, oh, I didn't tell you about these guys, these 2 peaks. That is, where is it? This Kozai-Lidov mechanism. And it has to do with a interaction between the sun, Jupiter, and a small body. It's a 3-body problem thing where you have 2 big things that are attracting a small thing. And it exchanges between eccentricity and inclination. I'm not going to go into it, but they figure that it will sweep some of the particles out 7 degrees. And when you, so these 2 peaks here are the 1.8 degrees or 1.4 degrees that Mars is at an inclination to the ecliptic, and these 2 are with that Kozai-Lidov mechanism spreading some of those particles out. And they said, there's no way that this is a coincidence. The parsimonious, the simple, elegant solution is that Mars is the cause of the zodiacal dust. Anyway, the reason I did this is escape from Mars would require overcoming escape velocity of 5 kilometers per second, for which no mechanism has yet been identified. And multiplying 5 by times 60, 18,000 kilometers an hour. No. Yes. 18,000 kilometers per hour. 5 kilometers per second times 3,600 is 18,000. Right. Whereas the fastest, I Googled this, I don't know how true it is, but apparently somewhere in Australia, they once got 408 kilometers an hour. It's a lot slower than 18,000. So they don't know where this dust comes from. And I think that's where I'm stopping. Just with another picture from John from, I don't know where. I should have taken a look. But most of the pictures in Zenfolio, when you look up zodiacal light, are from John. And another very nice picture of it. And that's where I'm stopping.
That'll be from New Mexico.
Yeah.
Rodeo, New Mexico.
Excellent.
Very cool topic.
Great. Thank you, Randy.
Well done, Randy.
And again, thanks to Natasha for pushing me down this crazy rabbit hole.
But it's still a mystery, is what you're saying.
But it's a lot easier than the comets. It really, like Brian May said, it can't really be comets because everything was going prograde, whereas the comets are half prograde, half retrograde. So he was more in the asteroid collision camp. But even that didn't really work.
That's quite fascinating. Thanks, Randy.
Yeah, very nice.
So Randy, while you were talking, I was taking in every word, believe me. I did look up how much gas we're actually traveling through here at the Earth. In every 100 meters by 100 meters by 100 meters, there's 1 particle of dust. So we're okay.
That's all.
How big was it?
Oh, that was one of those 10 to the minus 16 things that Randy was talking about.
Fantastic. Thank you, Gary. I know
But
that
not
they've
much.
estimated that the whole, if you took all of the zodiacal dust and put it into one little asteroid, it would be like 16 kilometers diameter. And that would be very hard to see in a telescope, whereas people can see the zodiacal light with their naked eye.
Yeah, it's amazing.
It's totally out of proportion to the amount of stuff. And it's one dust particle per cubic meter. That's crazy.
So Gary, you make that sound safe, but it is pollen season, you know.
Yeah, respiratory problems.
Aren't we sitting on a big hunk of dust?
More than 30 microns.
Disembodied head says.
Well, it
Okay.
is an amazing topic, and I had no idea it was so complex. The original question arose from the fact that after reading about it in the handbook, I realized that my late husband and I had actually seen it several times we've been around the world 3 times, at sea,
Yet.
but had no idea what it was.
Wow. Like
Okay,
you were all boat?
Ships.
Natasha?
On small ships.
But with no lights on.
No lights on. No, it was a very unusual ship.
Okay, I just noticed Ada popped an image in of the micromoon. So I'll go there, and then David, do you want to get set up for your deep sky stuff? Okay. Let me try that again. So that's just a little short sequence from Ada. And are you almost ready, Dave?
Thank you, Ada.
Yeah, thank you. Dave, are you almost ready?
You're on mute.
We can't hear you, Dave. Oh, there we go.
He's still on mute.
There we go.
Oh, excellent.
Wow.
Thank you.
I had to turn a light on so I could. It got quite a bit dark since we've been talking. Anyways, I happened to finally get around to processing a couple of images I took in December and January. So as you know, there weren't very many good opportunities to take images. I had gone into the winter saying, every time there's a break in the clouds, I'm going to get out there and do the southern sky. But unfortunately, that never materialized. So this was the Rosette Nebula. So there's stars a cluster of stars that have been formed in the middle of this nebula. It's 5,200 light years away, just a little over 5,000 light years away, and it's 65 light years across the thing. Now, it's there's lots of interesting things I was trying to capture, a lot of this dust. There's a bow front, something creating a bow front here in this bright blue region. But it tends to follow the classic star cluster pattern that you tend to see in these nebulas, particularly when you're imaging it with narrowband light. You see a lot of blue in the middle, and that's indicating that oxygen's being ionized, doubly ionized. So So the UV radiation there is really strong. And then towards the outside, you get a mixture of, here's a hydrogen bank um, um, that's been pushed away. This cloud actually formed that star cluster, but now the stellar winds from all these stars are blowing that hydrogen away, and it's getting bombarded by weaker UV light than makes the blue, and that ionizes sulfur. It also ionizes hydrogen, and when hydrogen recaptures its electron or sulfur electrons move about, it gives off the rest of the light. So it's a really beautiful object. I did mute the colors on this one quite a bit, and it's kind of a famous nebula in the dark sky. I did take a slightly different color palette on this second image. This is the California Nebula, and this is what I really wanted to show you. And I think I've been spoiled because, well, not spoiled. I think I was put in a way of looking at this thing because it's called the California Nebula, and it looks kind of like the shape of the state of California. But you're used to seeing California like that on a map. So you kind of think of it as this flat surface. And what was fooling me at first was that it seems to be bright on the edges. And I tried to figure out, well, where's that UV radiation that's making this light up along the edges? Where is it coming from? And there's a little star up there, but it's kind of a tiny star. But I did happen to know that there was a star down here. And the fact that the bottom of
Where?
down below what I actually imaged.
Ah, okay.
Away from there.
So you can't actually see it, but it's there. And I was just totally confused by these bright edges and thinking that it's this flat object. And it's actually 1/5 as far away as the previous nebula I showed you. And it's about 22 light years from left to right in this image. But after I stared at it and stared at it a while, I couldn't reconcile. I finally reconciled it with that circular spheroid that we saw in the other image. And how I finally saw it, and I had to stare at it for a while, and I still have to stare at it to get it in my mind, is that all the UV, all the lighting up, the light source is all from the bottom of the image, from below the bottom of the image. This actually forms almost an inverted bowl or dome in the sky. And this is one edge, and this is off the edge. It's like the cloud has been totally blown away. And this is farther away from us, this edge. And you can see that it's like a cup almost. And there's lots of neat textures and features in here. I just want to point out one is down here. It's got almost a texture. If anyone's imaged the Fox Fir Nebula, it's got that almost furry texture to it. But you can see all sorts of nice eddies and turbulence in the clouds, ready to make some new stars, perhaps, and lots of undulations as the stellar winds are making inroads into the cloud.
Looks like a mountain range.
Yeah, And
David, zoom into that black thing right in the middle. That's an amazing feature.
yeah, so this is it actually throws off the perspective because this is a dust dusty region that lies between us and the cloud behind it. So it's like someone spilt some ink on top of the image. And the light is actually hitting that cloud from the far side. So we're seeing it in profile.
Hmm.
You can see up here, there's some more strands of cloud too. But it's really not on the cloud, it's in the foreground from the cloud.
Yeah, spectacular.
You have to stare at these things so long to get your perspective right. What's
So
closer, what's farther away.
Dave, the red would be ionized hydrogen, is it?
Yeah, the red is actually the yellow to red is hydrogen that its electron has been stimulated into a higher orbit by the UV light, and it's actually moving down, going back to the ground state. And that gives off, in this image, it's giving off a yellow color. The reddish part is coming from ionized sulfur.
Oh, okay.
And the blue down here is doubly ionized oxygen. And it's blue down here. It's not that you're so much looking at oxygen versus sulfur. It's that you're looking at higher frequency, stronger UV light closer to the star here than up here.
Okay. Dave, could you please go back to the picture of Rosette?
Yeah.
Now, you said something to me a long time ago that, well, not that long ago, that intrigued me. Like it looks like there's a bigger concentration of the oxygen, the blue, towards the center where the explosion initially occurred. And I think that if I understood you correctly, that oxygen being a lot heavier than hydrogen would move more slowly. It would have a different momentum than the hydrogen. And that's one reason that it would be closer to the center. Do I have that
true.
right?
That's true. If there was a lot of hydrogen here, it would essentially be swamping out the oxygen signal.
Yeah.
And
So, David, is this a supernova remnant and there's new stars being formed in the middle there?
no, it's not a supernova remnant at all.
Okay.
I can see why you would say that, but it's actually a cloud, and clouds form where it's cold and there's turbulence, and that causes the hydrogen to condense into a star, basically. And then it ignites. And once it ignites, it sends out its stellar winds, protons and alpha particles, as well as a whole bunch of radiation. And then that sort of blows the cloud away.
Wouldn't the oxygen come from the supernova remnant, though?
It could be from just a simple nova. It just exists in the molecular cloud.
Beautiful photo.
Very nice.
Yes. Amazing detail, too.
I see something rather unique down in the bottom right. It looks, we're looking at the rosette, and the pillars of creation are not in the rosette, but if you were to move over a couple more inches, there's a section down there in the darks that look like the pillars of creation.
Yes, that's all these things are like the pillars of creation. They're all like the The elephant trunk is another example. So these, as there are parts that are concentrated in dust and parts that have less dust. So you can imagine as these stars are blowing away this this cloud, a bunch hides behind some dense bits of dust. So it shields the cloud, and the dust has um, even if it's a micron thick, it's multiple atoms, and it has takes a lot of blowing by these stars to move the dust. So it kind of goes around the dust. And often you'll see within that dust, which is also a necessary ingredient to create stars, actually stars are forming in these little pillars. And you can actually see some coming out in the pillars of creation. Over here, there's a good example. I can zoom in. You can see these pillars.
Yeah.
Yeah. So
Oh.
And then here was kind of an interesting thing. There's something giving off some radiation, and it's creating some bow fronts over here. So the materials probably got oxygen in it, but is hitting it, and it's being held up by something being radiated from the other side. You can see wisps, because this is actually a sphere. You just see the edges of it because it's you're looking along the side of a sphere, but you can see little bits, wisps and stuff of hydrogen that are likely in the foreground here too.
So that center section then, would that be when you mentioned there were like radiation in the middle there?
Yeah.
Would those be dynamic to the point where you could see change in those by photographing at different times of the year? Or would those be like a flare, let's say a flare on the sun type thing?
You can catch what are called Herbig-Haro flares on newly or stars that are just getting created.
Okay.
But you don't see any dynamics. Like you see a
Right.
still of the dynamics, but the time change, these are just so big.
Yeah.
It takes a long period of time for it to.
You can see dynamics. So some guy took pictures of M1 over 10 years, and you can actually see things moving inside.
Yeah,
right?
you can see
That's
you
cool.
can see a pulsar going back and forth,
Yeah.
pulsing inside M1. Yeah.
And also some shock fronts are moving as well.
Yeah. You'd have to be very diligent on your time gap between taking them and trying to measure how much it moves.
Yeah, it took him 10 years.
But sure.
So Dave, do this again in 10 years. We're waiting for the
I want to see it move.
Alrighty. This one looks messy, you know.
Yeah. It is messy, but it's there we go.
Yeah, it's very good, very good.
Yeah.
Great. Thank you, David. I just noticed Wade just popped something into the chat. I'm just gonna bring this up. Did you want to comment, Wade?
Oh, I just posted that because that one section in David's picture there down at the bottom right, I was looking at the stars on the points on the pillars here were so much in line with his photo. It was like it looked like these pillars here belonged in his picture, you know.
I see.
I captured this one last summer, I think. I didn't get it cleaned up that much, but I was playing with it, trying to look at depth, you know, where trying to understand the different clouds and whatnot that were going on in here.
Mm. Yeah, nice.
Yeah, it takes a while to get your frame of reference.
One interesting fact about the Rosette Nebula is in 2019, the Oklahoma legislature passed that it made the Rosette Nebula the official state astronomical object.
I see.
Oh, I'll have to,
Whatever they want, if they have such a thing, I guess.
Did it
Well,
actually happen, Reg?
Pardon me?
Did it actually happen?
Well, they did this, yes.
Oh.
On the date, I've got the date. It was
Was that Yokohama?
it was April 16th. Coming up, an
Yeah,
anniversary of it.
You said Yokohama, right?
No,
Oklahoma.
Oklahoma.
So we should have a British Columbia astronomical object, I think.
Yeah, we should.
well, pick one.
Rain.
Find something in the shape of a beaver, Dave. That is
Yeah.
I think
Or
I
can
think we will go to
Can
Chris Gainor actually now for some space news, please.
Okay. Well, earlier on this evening, we discussed the all-women crew that went up today on the New Shepard rocket, just a 11-minute up and down flight. And that's the first vehicle going into space since the very first one, which was Valentina Tereshkova by herself in 1963.
All female, yes.
So there was actually the Russian Soviets actually one stage were training a 3-woman crew to fly, I think in the 80s, but I forget something went sideways and it didn't happen. But anyway, the big news going on, I think when I was speaking last week at the meeting and all that, I was hoping that the political developments in the States would take a positive turn in terms of space. And a couple of days later, I heard some not so good news. Now, NASA has been relatively untouched, except they fired the chief scientist and basically shut down that office. I'm not sure why, but they did that. But I think on Thursday, anyway, later in the week, part of the budget for NASA was leaked. Now, the budget, the U.S. budget, they're usually it will be out by now. It usually comes out in March, I think, or early in the year. But because of the change of administrations, it hasn't happened yet. But a draft budget was sort of put in front of NASA for comment before it became official, and it's not a good one, and it leaked as what happened. It's talking about basically a major cut, like 50% cut in scientific programs of NASA that would affect things like Hubble and Webb and perhaps even keep the Nancy Grace Roman telescope on Earth. And then rumors that the Goddard Space Flight Center, which is the most important NASA center nobody's ever heard of, that would be closed, which would be a disaster, I think. Yeah. That's where Hubble and all these things are controlled. So there's the best reporter on what's going on in the U.S. space program right now is a guy named Eric Berger, who works for Ars Technica. So if you go to the Ars Technica website, anyway, he got the leak and published a story about it. anyway, this has caused a lot of concern. You know, I got because I'm in the history division of the American Astronomical Society, and I got an alert saying, you know, write your congressperson and all that. So anyway, this is causing a great deal of concern and a major cut in scientific funding. Now, is it a done deal? No. So first of all, we have to see what is officially released when they finally get around to releasing the budget. And usually they release the whole works in one day, and including the NASA budget. You have to go to things, you know, websites like NASA Watch or something like that, or Space Policy or something to find out what's going on in NASA. In the US political system, of course, the president proposes and Congress disposes. But right now we have a Congress that is basically surrendered all its authority to the president. But having said that, when we get into the nitty-gritty details of the budget, there may be a lot of changes that restore these things, because over time, there's been lots of proposals made from the White House that don't get past Congress. You know, for example, you know, usually the Maryland congressional delegation works very hard to preserve things like the Goddard Space Flight Center and things like that. So we'll see what the official proposal is. We will see what Congress does. But a potential concern is that in recent years, Congress has, for a variety of reasons, has not actually passed the necessary resolutions to put the budget in force with whatever changes that Congress wants to make. Is there a musical thing going on here? Somebody's phone is going? Anyway, and so.
Are you leaving, Kathy?
Yes, I am.
Bye.
That's great.
So basically what happens is that the resolutions that are necessary to bring spending into force aren't passed, and it's kind of thrown back into the White House, which would not be a good thing. So I'm afraid we're in for some nervous times. Now, another event that happened last week is the new administrator of NASA, Jared Isaacman, had his confirmation hearing, and they haven't had the vote on his confirmation yet. But you know, there's no suggestion that he won't be confirmed. In a lot of ways, he seems to be good. You know, he's not a particularly political figure, although he is known to be quite friendly with Elon Musk. At his confirmation, and for example, he is quite strong about things like Hubble. Like he personally has been proposed before he was appointed or got this NASA nomination. He was pressing NASA to launch another Hubble repair mission using Dragon spacecraft, which is a whole other thing maybe we can talk about another time. But that sort of gives you his attitude. But at his hearing last week, he was very cagey about everything. Now, well, part of it is that, you know, they don't you know, tell you what's in the budget or all this sort of stuff until you are actually the administrator. So he may not know, but he was being he was being very cagey, got a lot of questions, what are you gonna do, what's gonna happen, and he was avoiding answering them, and which has caused concern. And most of the questions were actually about Artemis. You know, the human space program to the moon, and also how much they're gonna put weight they're gonna put on going to the moon and going back to Mars. But so anyway, that's added to some of the concern about space science. So we will be watching to see what happens, but you know, it's kind of a worrisome time for space science and NASA.
So stay tuned, right, Chris?
Stay tuned. That's right. That's
All right.
right. I mean, it's just this is kind of a time of endless drama. You know, I pitch myself, but you know, it just seems one thing that this president, this administration want a monopoly on is on everybody's attention. You know, like every day the tariff situation changes, and it seems to be going on in all sorts of different places, including, you know, the NASA science budget, which of course is peanuts on the larger level of how much they spend on things. So we will see what happens.
That's great. Thanks, Chris. So we only have two items left. I think we'll go with Lauri first. Lauri, tell us about the GA.
Okay, so I'm hoping that people have signed up already for the GA. We are meeting on the Saturday, April the 26th, and Sunday, April the 27th. Because we are out west, our programs are going to be starting at 9 o'clock. That's 12 o'clock out in the east, and 1 o'clock for the people in Nova Scotia. And then we'll go through until about on Saturday until about 4 or 5 o'clock our time. Now there are some breaks in there, so there's two streams that are going to be filled with workshops through the two streams, and you can hop between them completely as to what you'd like to see, and the whole schedule is up on the website. If you go to the GA, I think it's like GA RASC GA 2025 or something like that. I haven't got it in front of me. I'm sorry. To go there, and you'll get all the information that you'll need. And if you have signed up already, then you will get the links for the different programs just about a day or two before, because Jenna always found that if she sent things out 2 weeks before, there would be an absolute flurry of panic. These people wouldn't be able to find them, and they'd be she'd spend 2 hours on the first morning trying to get everybody else to get linked up. So she felt, okay, all the links are going to be out pretty pretty close, so that they'll be up in the inbox, fairly high on the inbox, so that you'll be able to find them. So I hope everybody will come in for a little bit that can. And you'll see yours truly with David Lee and Kirsten and Chris Peirce. Well, okay, sorry, not Kristen. Kirsten, David, and I doing a program for Nova, and Randy will be doing his program on the moon occultations, or the moon
Timings, right?
timings, moon timings for citizen science. There's lots of citizen science programs going on, lots of stuff on photography, right from the things that David Payne does to the things that I would do is I throw up my iPhone and go click, and like lots of different things in between. So come on along and just dip your toes into some of the things sometime on the Saturday or sometime on the Sunday. So
There's going to be the usual after hours socializing in Gathertown
yes,
as well, right?
GatherTown. If you've not been there, GatherTown is a social space where you get your own little avatar and you wander around. And if you bump into somebody that you know, when you go close to that person, you'll be able to hear the conversation. So you just kind of wander around this space and then just kind of wander through and talk to people as you get up close to them. It's really quite fun, and not intimidating at all. It's really quite cute to be kind of doing this. So we'll be
Yeah,
doing that on Saturday night.
you get to meet the people from all across Canada actually,
Yeah,
which is nice.
yeah. Because this is the one thing that we have really missed. I mean, basically since 2019, actually, is that there hasn't been an actual in-person um, General Assembly, and since I believe 2018 was the last time, and we had it in 2014.
2019, the last one.
2019 was the last one.
Yeah,
Oh, that was the one in Toronto.
that's right.
That's right. Yes, that's right. Sorry. And so then after that, it's all been online. And I mean, it's certainly, there's pros and cons. If you put it online, then, I mean, for a fairly small amount of money, like about $30 or so for the weekend, you can have the entire GA at your fingertips, and you don't have to get on a plane. You don't have to you don't have to be, somewhere else and get accommodation. And I mean, even like Chris can tell you, I mean, we were paying hundreds and hundreds and hundreds of dollars back 10, 15 years ago in order to go to a GA. It was a major deal. Now, just about anybody can join from right across the whole country. But you do miss that uh, listening or seeing people and chatting to people and having those kind of conversations. The Gather Town is a place where you can get together with people that you haven't seen for a while and see that. So yeah, hopefully everybody will come in. And if you need any other information, just give me a quick email and we can get you settled.
Okay, that's excellent.
Thanks.
Thanks, Laurie. So there is one last item to deal with before we sign off. We have to make some decisions. So next week is Easter, so that's not on. But the session after on 28th, I guess, that's probably election night, I guess, or near election night. So we're wondering whether we want to. Pardon me?
It is election night.
Yeah. So we're wondering whether we should cancel. So does anybody have any feelings, strong feelings either way? Would anybody miss just missing that one and then waiting until the 5th of May?
I think it'd be a good idea to cancel it.
Yeah. Okay.
Are there people who are saying, oh dear, I was trying to find a way to avoid the election?
I guess not.
Okay, so the deal that means is there are, I think, I wrote it down, but is it 2 more or 3 more before we go on hiatus for the summer?
It should be 4 in May, or it depends for the Mondays, or it doesn't.
Yeah, because there's
We
Victoria
lose
Day.
one Monday.
Anyway, I will, unless anybody says, I'm very disappointed, I will write the community center and say that we're going to stay home. And
Okay. So the next actual schedule.
so there's 3 left after today.
5th, 12th, and 26th.
Yeah, I think Kirsten is the 5th, Lauri is the 12th, and the very, very last one, Randy.
There we go.
Okay.
and then we'll start again after Labor Day.
Yeah.
But that means there's all the more reason to get together with our telescopes at Cattle Point or up at the VCO.
Yeah, I mean, hopefully there'll be a lot of pop-up cattle point things. We actually might make a list, a separate list for that. Right now, we've been offering it to the beginners group, but we're also thinking about just creating a separate cattle point list. The other thing is, come on Saturday night star parties. They're going to start getting regular after Astronomy Day, and then yeah. So that and VCO, of course. So once we get VCO all squared away, we'll be inviting people up. So anything else? Any parting words? If not, have a good evening.
We'll see you in May.
Take care.
Thank
Bye.
you.
David.
Yes.